Everyone, we will solve this today's LeetCode problem. This is LeetCode medium, magic squares in grid. Let's see what the question is asking. So we have given a 3 cross 3 magic square and which is filled with the distinct number from 1 to 9 such that each row, column and both diagonals all have the same sum, right? Given a row into column grid of integers, how many 3 cross 3 continuous magic square subgrids are there? And we have a note that magic square can only contain 1 to 9 numbers, but grid may have contain numbers up to 15, right? So basically it is asking us to find the count of submatrix of 3 cross 3 which contains only numbers 1 to 9 and should be distinct, right? Means any number from 1 to 9 cannot be duplicates, right? So the 1 to 9 should be there and also all numbers should be distinct, and we need to find the count of submatrix 3 cross 3, right? Also grid can contain from 0 to 15, right? Grid can contain 0 to 15, so 15 is included and 0 is also included, right? So how I get that? By seeing the constraints, right? If you see, constraints are given that grid can contain 0 to 15 elements. So basically we need to find the total number of counts, right? So one thing is to clear that all the rows, right, each row, column and both diagonals all should have the same sum, right? All should have the same sum. So how we will check that, right? So if you see the constraints here, so first I think of that I without seeing constraint that I need to solve it some like dp or something like that. But when I see the constraints are very small. It is given that row and column is only 10, right? And if I traverse it, suppose two times, or o of n square, right? O of row into column into whole square, then it goes to 10 to the power 4 only, right? It goes 10 to the power 4 only. So which is very less, right? Which is very less. So it means I can simply use brute force. I can simply use brute force approach. I can simply use brute force approach, right? So how we will use brute force approach? So one thing is, first thing we will see that the example first, right? So this is the matrix given, 4 cross 3 matrix. So how many 3 cross 3 magic square can we form, right? So if you see the first 3 cross 3 matrix, which is this matrix. So 4 3 plus 8 is 15, 9 plus 5 plus 1 is 15, 2 plus 7 plus 6 is 15. Same for columns, 4 plus 9 plus 2 is 15, 5 plus 3 plus 5 plus 7 is 15. Same for 8 1 plus. And also diagonals, right? Both diagonals means from 4 5 6 8 5 2, right? This is two diagonals in the square. So if you see the summation of 4 5 6 and 8 5 2, both have summation 15, right? It means the row sum is equals to column sum is equals to diagonal sum, right? So these all conditions satisfied. Also, if you see, they are all distinct number from 1 to 9, right? There is no repeating elements and all numbers are between 1 to 9. So 1 to 9 distinct numbers also satisfied. It means this is a part of, this is part of our answer. So we will count it one, right? Now when we see other one, which is 3 8 4 5 1 9 7 6 2, because only these two square matrices is possible. So if you see this, 3 plus 8 plus 4 is 3 plus 4 8 plus 4 is 15, right? 5 plus 1 plus 9 is 15. 7 plus 6 plus 2 is 15. Row sum is correct, right? Say, when we see column sum, this is 3 plus 5 plus 7, which is same. 8 plus 1 is 6, same. 4 plus 9 plus 2 is same. But when we see diagonal, 3 plus 1 plus 2, which is 6, which is not equals to row sum or column sum, right? Same for 4 plus 1 7, it is coming 12. So it is not satisfied. All the numbers are distinct, all the conditions satisfied, but the summation which are equal for row, column and all the diagonals are not equal. So this square matrix is not part of our answer. So total number of count is 1, right? That's how this is 1, right? So basically we need to just check that whether we can satisfy these two conditions in matrix, in each 3 cross 3 matrix possible, and we will just count it, right? So this is just a brute force approach, right? This is just a brute force approach because constraints are very low, right? Constraints are very low. So what we will do, we will just check for each and every 3 cross 3 matrix by iterating, and just count it if condition satisfied, right? So let's start from grid. So first thing, we will see the row number of rows, second, number of columns. Now what we need to do, we need to iterate for each 3 cross 3 matrix. So what we will do, we will start from iterating I to n for int j 0 to less than n, right? Now, one thing to note, that I cannot move till n. I cannot move till n because I need 3 cross 3 matrix. So for 3 cross 3 matrix, if you see, I can go only till this column, this first column starting from 0, 0, 1. I can go till only 1 because for forming 3 cross 3 matrix, I need last three columns, right? I cannot move to 8 and see that whether we can form 3 cross 3 matrix, because we cannot form. So I can move till n minus 2. Same for column n minus 2, the less than n minus 2 row and less than m minus 2 row, right? So if we have four rows, then I can move to only 0 and 1, not 2, right? That's why I have taken n minus 2 and m minus 2. Now what I will do, I will check for each 3 cross 3 matrix whether these two conditions satisfied or not. Row sum, column sum, diagonal sum, and 1 to 9 distinct number also satisfied or not, right? So what I will do, I will check that whether the current 3 cross 3 matrix satisfied or not. Suppose it's satisfied, so I will just count, increase the count, and at last I will return the count, right? So let's just make a count variable for answer. So if the check function is 3 cross 3 matrix and it is satisfied all the condition which is given, so I will increase the count. Now main motto is to implement this check function, right? So what I will do, the first thing is I need to check for each 3 cross 3 matrix, right? So this is vector, always pass it by reference, right? Not pass it by value, right? Because it will create another copy which will take extra time, right? So always pass it by reference. So again, what we need to do, we will just take the size of this, and now we will need to check for we will need to check the 3 cross 3 matrix. So this is the starting point, right? So what we will do, we will check for 0 till, or you can write like this, row till I plus 3, right? I plus 3, and this is row plus plus, right? Same for column j, then till where I plus 3, column plus plus, right? Sorry, j plus 3, right? So what is happening here, the row is starting from I till I plus the 3, it will increase till two values next. Same for column j and j plus two values next. Now what we will do, we will check for grid, that whether this element is within our limit, which is 1 to 9, right? Because it is given that we can have more than 9 numbers, right? So if we will check that whether this number, grade, row and column must be greater than 1, and it must be it must be less than 9. If it is satisfied, so if it is satisfied, then we will move further. Otherwise we will don't move further, right? So instead of checking this, we will just also we need to check that whether there are all distinct numbers or not. So for that, I will just take an extra visited array which will be of size 10, because we need to see for 1 to 9 numbers, and for greater less than 1 and greater than 9, I will not see this, right? So instead of checking this, that it is greater than 1 or not, can I do like this? If it is less than 1 or if it is greater than 9, I will just return 0, right? I will just return false, right? If it is less than 1 or greater less than 9, because we cannot can have only 1 to 9 numbers. Also the wasted numbers, right? We can have distinct numbers. So if, again, if this wasted grid, row, column is equals to 1, it means we have already wasted it, it is repeated number, so we will again return 0. So instead of writing like this, we can also write it in here, Why can I write it like this? Because if both any of this is true, it will automatically return 0. If both is wrong, then it will execute this wasted, right? So it means we are safe, we will not get any runtime error for this, right? If it is greater than, right? So we can write like this, right? Now what we need to check extra that. So if this is not wasted and we are passed on after this, so we will just mark it as wasted, right? So if I mark it as wasted, it will become 1, right? Now, one thing is to note that I also need to find row sum and the column sum for each row and each column. So for that, I will just take an extra vector. Let's make it here as well. Row sum, which will be the size of 3. Also, take it as column sum, right? Which is also a 3 0, right? Now, what I need to do, I will check for each number, right? So, okay, one thing is to know that if I want to check it in this same loop, I need to do some modification. So instead of writing I plus 3, can I write like this? And r, it is the same, it will be the same thing, right? It will be the same thing. Row plus I and int is c, column plus j. Why I'm doing this? Because I will initialize this to 0 to 3, because I need this row sum and column sum, so I will do some modification. Don't be confused. I'm just changing this to R and C. It is the same thing, right? Row plus I is the same thing. Starting from row and the initial position is I, right? So it will move to 0, 1, and 2. It will same 0, 1, and 2, right? It is nothing like that, right? So I will just change this to RC, right? Don't be confused. It is the same thing. Why I'm doing this? Because I need row sum and the column sum in the same loop, right? I'm just implementing row sum and the column sum in the same loop. So row sum will be, okay, row sum will be according to the row value, which is r, right? Which is the row value, right? And this will be the grade row, grade r plus c, right? Grade r plus c, right? Same for column sum. Column sum will be for column, and that will be grade r plus c. So what does it do? It will store for each row summation and for each column summation in 1 to 0 1 2, right? 0 1 2. That's why I have taken this as 0 1 and 2, right? It will store for each value. Now after this completion, what I will check, I will just check that whether this row sum, if it is not equals to this, it's one time, or its row sum is not equals to its row 2, I will return 0. Both can be true. Or. Same goes for column sum. Same goes for column sum. Just paste it. Just copy it out. Same goes for column sum. Just change its name. Column sum. Column sum. Column sum. So it's just a brute force approach, right? So that's why it is taking some, need to some manual work, right? Also, one last condition need to check that whether this row sum 0 should all is not equals to the column sum, then it's also not be true, right? So all these conditions must be satisfied. If any of the conditions is not satisfied, we will return 0, right? Also, I need to check diagonals. So first diagonal would be grade I j, the first element, the top left, then center one will be grade I plus 1 plus j plus 1. What is I and j? The starting point of the sub matrix, and the last one is grade I plus 2 j plus 2. So it is starting from the top left to the bottom right. Same goes for opposite direction. The the top right, which will be grade I plus grade I plus 2, sorry, grade I j plus 2, right? This one plus middle one, and the third, the bottom left will be I plus 2 j, right? This will be the d1 and d2. If this d1 is not equals to d2, or if d1 is not equals to row sum 0, in both of the conditions we will return 0, right? And after that, if all the conditions are satisfied, I will return 1. So what is happening? I am checking for row sum, column sum, and the diagonal. All must have equal values. If any of the values is not equal, we will return one, return zero. Otherwise, of all the conditions satisfied, we will return one. Right. So this is how we solve for each and every 3 cross 3 matrix and check for each and every one. So we just try to run this. Hope I have not making any compilation error or runtime error. Okay, I have made some mistake. Something missing. 43849 Let's debug this. Right. Let's try to check that whether we have calculated the correct row sum and column sum or not. Cout it for I. I think I have made some mistake in calculating the column sum and row sum. Cout it. Let's also print d1 and d2. Right. Let's just analyze. Yeah, it is coming 10 and 15, which is wrong. It should be 10 because the first matrix is equals, right? It should be 10. What is wrong? I plus 1. Okay, this should be I plus 2, right? Because it is a bottom right? That will be I plus 2. Now it will be correct. Yeah, we have passed the sample case. Let's just submit it. We have passed all the test cases, right? So this is brute force approach. So basically what we are doing, we are checking for each 3 cross 3 matrix in the whole matrix, and checking for each and every one that whether we are equals to not. So basically the time complexity would be just O of n into m, and we are iterating the same rows or columns only three times, right? Only three one, right? So suppose 438 is here, and suppose we have taken this 438 and 951 and 276, right? So this 951 will calculate first for this matrix, then for this matrix, right? So basically it is something like you have just taken uh, three times for each rows or each column, right? So basically it is just a constant one. So ultimately it will be O of n into m, and the space complexity would be, again we are taking extra space, extra arrays for visited, row sum, column sum, right? So that was again, if you want to consider that, you can consider that. Otherwise that is O of 1 only, because we have just taken nothing, no arrays, because this is O of 10 and something which is O of 1, right? So that is O of 1, you can consider that because that's our constant spaces and then time constant, right? So this is how we solve this question, right? But one thing's to know that this is a magic square, right? Although this is also true because it also satisfies all the conditions, and this is just a brute force, it's just an implementation purpose. But a magic square is something like it should have 1 to 9 elements, right? It must have 1 to 9 elements, and in 1 to 9 elements the summation would be 45. If you sum from 1 to 9, the summation would be 45. And if each row and columns and diagonal sum all are equal of 3 cross 3 matrix, in 3 cross 3 matrix, so that would be 45 by 3, which is equals to 15. So instead of checking each and everything here, if I just check that whether all the row sum, column sum, and the diagonal sum is 15, then it is also true, right? It is also true that each row and the column sum and the diagonal sum must have 15, right? So you can use this, and there are also many facts about magic square, but that is just for knowing the facts about magic square. But if you want to solve this type of questions, you just need to use brute force, right? Because for observing these facts and at the same time in interview will be much difficult for everyone, right? For me or for else, right? So yeah, this is how we solve this question. Hope you understand it. Thank you so much. Bye bye.